today's video, we are going to discuss the auxiliary input and output board for our ATevo battery chargers. We will take an in-depth look at the capabilities and benefits of this advanced ATevo option. So let's jump right in. What is it? Well, in simple terms, it's an optional component for any ATevo battery charger. So no matter the DC output voltage and current ratings, or whether it is single phase or three phase, this option is available. One ATevo can accommodate up to 4 auxiliary input and output boards. However, keep in mind that smaller chargers in a style 5054 enclosure can only accommodate 2. One aux board will provide the following: 6 output relays, which will allow for remote alarming of charger alarms via dry contacts, 4 binary inputs, and 4 analog inputs that allow users to monitor third-party equipment. So what are binary and analog inputs? Well, a binary input simply detects the presence of a DC voltage and reports its status. So in basic terms, conditions such as a yes or no, on or off, and open and close would be considered binary. An analog input measures the DC voltage and reports its values. So essentially we are looking at things like ranges and can measure and or alarm based on a threshold on that range. We will discuss some examples of both binary and analog inputs shortly. So how does this option help? Well, this option will take any ATevo and turn it into the central point of your DC system. You will be able to monitor the charger remotely either through a SCADA system or other monitoring equipment using dry contacts that are completely programmable. The provided 6 relay contacts can be configured for any alarm within the charger, can be latching or unlatching, and can have the time delay adjusted. Also, you get the status and alarm of other third-party equipment via the binary and analog inputs. You can monitor status of vent fans, hydrogen sensors, breakers, battery monitors, and more. So let's take a deeper look at the specs. To begin, it's important to note that all terminal blocks are compression type and accept number 22 to 14 gauge wire. For the output relays, each aux board contains 6 configurable 1form C relays. These relay contacts are rated for a half an amp at 125 volts AC or DC. Each relay has a red LED that serves as an aid and will illuminate when the relay is in an alarmed state. Also, each relay has a second contact that feeds back the relay state to the ATevo main processor. Each relay can be latching or non-latching, and each relay can change states based on an alarm condition or status point. Each relay can have a programmed time delay, and finally, all relays are fail-safe. Now, for the 4 binary inputs, each of these can be configured via a jumper to accept input voltages of 12, 24, 48, or 130 volts DC. Each binary input has an associated yellow LED that when illuminated tells a user the input is high or in the on state. These can be configured to be active high or active low, and they can generate alarms as well as trigger controls such as charger shutdown. Each can be assigned a custom name based on what you have connected, and some examples of this would include hydrogen sensors, breaker status, vent fan status, and more. Now for the 4 analog inputs, each analog input is rated for 0 to 10 volts DC. They can be used to import generic analog values. Each can be assigned a custom name, and they can include scaling configurations such that ATevo can report values in primary units. They can also be configured to generate alarms based on its value and also based on available trigger conditions such as above a threshold, below a threshold, or within a range. Some examples of analog inputs would be items such as temperature or AC voltage. Now we will demonstrate how to configure the aux board. Let's start by configuring the output relay contacts. Here you can see we have our ATevo display on the home screen. To get to the relay configuration, you will press the menu key. This will bring up the menu screen, and from here you can use the arrow keys to scroll to find the relay's icon. Press the Edit Enter button, and now you will see options for the relay configuration. We will select Relay Configuration by pressing Edit Enter button, and now you will see all the available relays that can be customized. This example has one aux port, so we have 6 relays available along with the relay on the main control board. Let's select aux 1, relay 1 by pressing Edit Enter, and we can see the options available to be customized. First is Default. This allows users to change the alarm condition assigned to the relay. Once we hit the Edit Enter button, a full list of alarms will appear, and you can use the up and down arrow keys to select the alarm you want to assign to the relay, and then press the Edit Enter button. Now we can move to latching. To change the latching control for a relay, highlight the latching and press the Edit Enter button. Use the arrow keys to select either Disable or Enable, and then press the Edit Enter button. Finally is the time delay. To change the time delay, highlight Delay and press the Edit Enter button. Here again, you will use the arrow keys to adjust the time delay. This can be adjusted anywhere from 0 to 999 seconds. Once entered, you will press the Edit Enter button, and that's it. This relay is now configured. From here, you can go on to other relays and use the same procedure. You can get back to the home screen simply by pressing the Escape button. Now let's go ahead and configure the binary inputs. We will begin at the ATevo home screen, and we will start by pressing the menu key. We'll then use the arrow keys to scroll and find the aux inputs icon, and then we can press the Edit Enter button. Here you're going to see 2 options, binary input configuration and analog input configuration. We're going to select binary input configuration and press the Edit Enter button. You will now see the available binary inputs. For this example, you can see 4 inputs since we are using one aux port. So let's go ahead and select aux 1, input 1 by pressing the Edit Enter button. Now you'll be able to see the options available to be customized on this input. The first is alarm. This will determine whether the binary input will generate an alarm when it senses the alarm state. When highlighted, press the Edit Enter button, and you can use the up and down arrow keys to select either Disabled or Enabled. For this example, we'll leave it enabled. The next is a name. Each input can be customized, and to do this, we're going to simply highlight the name and then press the Edit Enter button. For this example, we're going to use a hydrogen sensor, or H2. To customize the name, you're going to use the arrow keys to select the characters, and then you can customize the name. This was already done on this unit, so we'll move forward. Now, we can go to the action. When we press the Edit Enter button, we have the option to assign an action to this input. This can be either None or Shutdown. For this example, we are going to select Shutdown, as this is common in applications using a hydrogen sensor. When the sensor alarms, the charger will shut down to prevent the battery from releasing more hydrogen. Finally, we have the active state. The binary active state determines the normal and alarm state of the input. Now, if we want to go ahead and change the active state, we're going to highlight active state, and then we were going to go ahead and press the Edit Enter button. We're going to use the arrow keys, and you can select either high or low. And that's it. From here, you can go on to configure other binary inputs or go back to the home screen simply by pressing the Escape button. Finally, we will demonstrate how to configure an analog input. Just as we did with the relays and binary inputs, from the home screen, we will press the menu button to access our main menu. From here, we will scroll to find the aux input icon and press the Edit Enter button. Here we will select Analog Input Configuration, and just as we saw with the binary inputs, we now see our 4 analog inputs available. We will select the first input, and it will bring up the items that can be configured. We will start with the name, and for this example we are going to use temperature as this is a common use for analog inputs. To configure the name, simply press the Edit Enter button and then use the arrow keys to change the name of the input. Again, for this example, we're going to leave it as temp for temperature and then press the Edit Enter button. The next item is units. ATevo can scale analog input values such that they can be represented in primary units. For this example of temperature, we have selected F for Fahrenheit. If we needed to change this value, we could press the Edit Enter button and then use the arrow keys to change the parameter. We're going to leave it at F again for this example. Now we will move on to the input scaling. ATevo can scale the analog input values such that the measurement can be represented in primary units. So for this example, we're going to use 0 volts to represent 0 degrees Fahrenheit. If we wanted to change this value, you could hit the Edit button and then use the up and down arrow keys to change that value. Again, we're going to leave it at 0 for this example. For 10 volts, we will use this to represent 100 degrees Fahrenheit. Again, we can change this value by using the Edit button and then using the up and down arrow keys to change this value. Next is the trigger. ATevo can generate various alarms based on analog input values. There are several triggers that can be assigned to define the alarm condition, which are below a threshold, above a threshold, out of a range, or inside of a range. You can use the arrow keys to select the proper threshold and then hit the Edit Enter button once you have made your selection. For this example, we're going to use above a threshold. So essentially we have our input set to monitor an input of 0 to 100 degrees. We want the charger to go into alarm when it sees an input that goes above 85 degrees. So we're going to select above a threshold. Now that we have done this, the high threshold parameter appears, and again, we have it set for 85 degrees. So essentially, when the charger sees the input go above 85 degrees, the charger will signal an alarm. Now, just like we saw on the binary inputs, we can select an action to occur. So if we scroll down, we now can select an action, which could either be none or shutdown. We can use the arrow keys to make our selection, and for this example, we're going to select shutdown in the event of a high temperature. So now if the charger sees the input go above 85 degrees, it will alarm and trigger the action for the charger to shut down. This input is now configured. You can press the escape button to go back to the other analog inputs and use the same procedure to configure those other inputs. If you wanted to go back to the home screen, you could simply keep hitting escape to get back to that screen. That concludes today's video. You can find more information on the auxiliary input and output board in the ATevo operation manual. If you found this video useful and would like to see more of them, we urge you to give us your feedback. If you have questions, feel free to reach out to us through the contact form on our website. We would love to hear from you, and we certainly appreciate you watching our videos. Have a great day.